Good morning, kiddos, and welcome to chemistry. So, I'm going to teach this subject this year a little bit different than I have in the past. I'm sure it's pretty obvious that you're watching a video right now and listening to my voice. That's because I'm going to present all of our lecture materials via video. So, since we're going to standards-based, this is called a flipped classroom. It's literally flipping the idea of what the classroom is. So normally you'd learn the lecture material in class and then be assigned some homework. We're going to do it where you actually have to go home and watch these videos, watch the lecture material, and then come into the classroom and do your work. So that could be practice sheets, that could be doing a lab, that could be group work, that could even be sometimes a class discussion because you didn't understand what was on the video. That's fine. But that's how it's going to play out this year. My goal is to make these videos no more than 10 minutes. Sometimes that's not going to happen because either I'm giving a lot of examples or the material is very dense. Your job as a student is to 100% watch these videos prior to coming into class. I know you have time to watch the 10 minutes, so I need you to do that. It also helps, think of this, if you happen to miss a lot of class for sports, or let's say you just come down with the flu and miss 2 weeks, or even you have a performance for 2 weeks in a row for the play or the musical, or band, whatever. You have this material easily accessible to you at all times, so there should be no problem and no issue with falling behind. So now let's start with our first real big lesson. Very basic, you want to know what chemistry is. If you've come into this class either thinking chemistry is all explosions, or two, knowing nothing about chemistry, you're pretty much in a good spot. Chemistry is, let's see if I can get the definition to pop up. Here we go. The study of the composition of matter and the changes that matter undergoes. So if you thought explosion, yeah, you're right. That is matter put together in a certain way, and it undergoes a change when it goes boom. If you know nothing about it, it can be as simple as if you've ever made scrambled eggs or a cake. You put some things together, it's usually like all liquidy and gross. You put some heat on it, and boom, you have something that's edible and solid. That is matter undergoing a change. So, most basic chemistry definition. Now, I'm going to do a bit of a difficult subject to start us off. I choose to do this subject because you have to know it from this day until the very, very, very last day of our year together. And it's called significant figures. I refer to it shorthand as sig figs, but sig figs are very important to the study of chemistry. It's all about pretty much precision and accuracy in measurements, and there's a set of rules that, if I'm being totally honest, you're going to hate up until the point that you fully understand it, and that's all right. You will get in the habit of doing it. They are always worth points on your test. But first, let's talk about what is a measurement. So a measurement is a quantity that has both a number and a unit. That's very important in any science. It's also pretty important just in kind of everyday life, right? Because if I just came up to you and was like, 220, you'd probably sit there and be like, 220 what? Like, what are you talking about? Are you 220 pounds? Have you eaten 220 candy bars today? Is your IQ 220? Do you have 220 classes? Like, that is just nonsense without having a unit with it. Similarly, if I just walked up to you and said centimeter, you'd probably wonder what was going on as well. In order to give an understanding and clarity to what we mean, we have to talk about both the number and the unit. So if my doctor really wanted to know what I had eaten today, right, I couldn't just say 7, right? In this case, my unit's not really a scientific unit, but for the sake of this understanding, I would be like, well, I've eaten 7 sandwiches today. And he might say, you need to slow down on the sandwiches. But it gives him kind of an idea, an overall understanding, number, and unit. So sometimes, though, those measurements that we have, our number is either ridiculously large or ridiculously small. And we don't want to have to write all of those little extra zeros or all the numbers that we have. So what we do is we use scientific notation as our way to express these really big or really small numbers. So if you look at the example I pasted on here, I don't actually know what that number is. I don't know if we're in the billions of trillions of gazillions. I don't know what it is, but it's ridiculous. And I used it for that purpose. Instead of saying on a test or in a scientific paper, having to write out every one of those zeros, we're going to use scientific notation and take that number down to, as you see, let me highlight it right here, 3.79 times 10 to the 20th. Way more reasonable. So what are the rules for scientific notation? Or how do you utilize scientific notation? How do you write it? All right, so our coefficient, which is the number out in front, must be greater than or equal to less than 1 and less than 10. So for this 379 billion, gazillion, whatever, we have to choose in those first three numbers a number between 1 and 10. That's where we get the 3.79. 3.79 is greater than 1, less than 10. Then, with that coefficient, we either move to the right if it's a very large number, or move to the left if it's a very small number. And also, clearly, we all make mistakes sometimes. By coefficient here, I mean exponent. Now, if you were confused as I'm writing this and talking through it or have no idea what's going on, chill for a second because I'm going to give some examples that hopefully help explain it out very clearly. Okay, so I fixed my little mistake there, and we're going to do some examples and kind of explain these terms. If you have never heard the term coefficient or you've never heard the term exponent, we're going to actually talk through it. So let's say you see this number. Let's write out a bunch of zeros right now. Let's see and make sure that I have the right amount. So let's say you took a measurement and this is your measurement in centimeters. That's ridiculous. So first things first, we have to figure out a coefficient, right? So if we, let me kind of zoom in, look back up here on this highlighted one, that's the 3.79. That's your coefficient. That's what goes in front of the times 10 to the. So in this one, our number would probably have to be 7.1 because it's greater than 1, less than 10. So we write 7.1. And I'm going to set up this times 10 to the. Now, our exponent is up here, that little 20 on top. It tells us kind of what to do. So I'm going to try and draw it in here and see if I can draw well enough for you guys to all see it. Let's change colors to orange. So we have technically, let's make that a little bigger, just put our decimal right here. Our other decimal, our starting decimal, our original one, is all the way down there. So we're going to just kind of move over through the zeros and count how many times we've moved this decimal. So I went 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we moved the decimal 10 places. So our exponent is going to reflect that. So up on top here, we're going to write a 10. But is it a negative or positive exponent? Since our number was super small, we're going to put a negative there. Because when you take it out of scientific notation, you are moving the decimal back to the left 10 spaces. So I took a minute to set up the other two examples, but hopefully someone caught that I just missed a very, very big important detail. In my answer right here, I'm missing something crucial. And that is, I have my number, but I don't have my unit. When you go from scientific notation to normal to scientific, your units never change. Units just stay the same. So all you have to do is pull them right over. So now let's go to the next example. I'm going to try and go a little faster. It's also a very small number, so we're going to utilize a lot of the same skills we just used. First and foremost, figure out a coefficient from all these numbers that's between 1 and 10. 53 is too big, 0.53 is too small, so let's go with 5.3. And then I'm going to set up my times 10. I'll make that a little bit bigger. And I'm going to go through and do the same thing with my moving of decimals to figure out my exponent. My new decimal is here, and I had moved 1, 2, 3, 4, 5 places. So I'm going to go up here, and put my exponent. Again, the number is really small, so that exponent's going to become negative. And this time, I am not going to forget to include my very, very, very important units of inches cubed. Perfect. And our last one. Now, this unit here, the mole, you will learn about later on in this class. But for right now, it does not matter if you understand the unit or not, as long as you know to continuously keep the unit with the number. So here we finally have a super big number. The rules still remain the same. We need to take these non-zero numbers or any of the numbers and get us a coefficient between 1 and 10. So right now, I'm going to make that 9.21. And I'm going to go back over here. I'm going to change my color up again, and I'm going to figure out how many places I move the exponent. Nope, move the decimal. We all make mistakes. Now, we don't actually have a full decimal place right here. There's no obvious indicator of a decimal. If there's no decimal and your number is very big, that means the initial decimal just existed on the end here. Oh, that's very hard to see. I'm going to make it very obnoxiously big. So, I'm going to go and figure out how many places did we move. So we got 1, 2, 3, 4, 5, 6, 7. So, I'm going to go back here. I'm going to remember to put my times 10 to the, and I'm going to write the number 7. Now, since this was a very big number, and in order to get out of scientific notation back to normal notation, we'd have to move the decimal to the right. We keep that number positive, add on our units, and we're good to go. Now, I started this video off by saying we're going to do sig figs, but I think right now this is more than enough information, so I'm going to stop us here, and our next video will actually cover significant figures. If I haven't said it before, and you've watched this video and are just mostly confused, my suggestion would be take notes off this video, right? Take actual solid notes that you can bring into class and kind of figure out where your questions are. And also come to class prepared with questions. If you say, I don't know, that doesn't give me a lot to go off of. But if you say, hey, I understood what you were talking about, with measurements, I'm going to try that again, right? And like, I get the unit and the number, but suddenly you got to scientific notation and you still don't understand what a coefficient or an exponent is. That's a great question to write down in your notes for me to talk about next class. Also, since this is our first video, please come to the next class with any feedback for me. It's too loud, it's too soft, you go too fast, I can't read the writing, whatever it may be. Your feedback's going to help make these videos more and more clear, better for you to understand going forward. Thanks, guys.